All right, howdy y'all, we're on the last one. All right, so we're going to be proving the C infinity Urysohn lemma. So what we have here is if we have a subset of R and K that is compact and contained in an open set U, then there exists an F in C infinity C such that F is bounded above by 1, below by 0, with F equal to 1 on K, and the support of F contained within U. Okay, proof of this one's not terrible. So we're going to start with delta. We're going to take the distance between K and the complement of U. And what we mean by this is the minimal distance between a vector in K and a vector in UC. Then the distance from K to UC is positive since K is compact and hence closed. So there is a boundary and I get a positive distance because I can't have the boundaries shared. Because if this guy, since this guy's compact and closed, it contains its limit point. So if they share a boundary, you would also have to contain its limit point. So we get that this distance is in fact positive and is not 0. So because of that, we can define this set V of X from the distance from a point to K is less than delta over 3. And here, delta was, again, the distance from K to the boundary of U, or to the complement of U, same distance. So we're going to define, basically, if I have my set K, we are taking V to be the set, to be this set, where this distance here is delta over 3, right? So we're taking a set that's like surrounds it by delta over 3. And again, K is closed and compact, so this has a very clean, because we're in Rn, so this is a very clean V. Okay, now we're going to let B be an element of C infinity C, with C being non-negative and with its integral being 1, and such that it is 0 when X is outside of delta over 3. So, in other words, it is the support of this guy is going to be the delta over 3 ball. Now, again, we know such a function exists because of because of the discussion in 8.1. So, what we now do is we define F of X. Sorry, F is defined to be the characteristic function of V convolution with this phi. So now, by the same argument that we used last time, here giving us compact support, and here giving us continuity, we get that F is in fact in C infinity C, and then we have 3 things to show. So we have to show first that F is in fact less than or equal to greater than 0, less than 1. So to do that, we note that if it's defined this way, but the characteristic function is always less than 1. So it's always either 1 or 0. So this guy's less than 1. So I can just go like that and say that this is less than this guy. And we know that this integral is 1 by hypothesis. So we get that this guy is bounded above by 1. Also, we get that the characteristic function V and phi are non-negative. So we get that the convolution must be non-negative because we're taking an integral across 2 non-negative functions. So that gives us the first condition. So this one's checked off. Now, okay, so now we have if X is in K, this implies that X is in V. Since the distance from X to K is less than is 0, so we get that F of X is equal to the integral of this guy, which is this one is going to be 1, which gives us that phi is equal to 1. And the way that we know that the characteristic function of V of X minus Y is 1 is since phi of Y is equal to 0 for all Y greater than delta over 3, when phi of Y is greater than 0, we get that X minus Y has to be in phi. So we get that the difference has to be in V because we know that y is less than this value, which means that by our definition of V, that the difference between them has to stay within delta over 3 from K by the triangle inequality. Lastly, again, by the triangle inequality, if the distance between X and K is greater than or equal to 2 delta over 3, then we get that X minus Y is not in V. So same argument, but now we've incremented it, whereas V was defined using defined using delta over 3. So if I make it 2 delta over 3, we get that it's outside of V for all Y inside of the ball, the delta over 3 ball centered at 0. And again, this is because by the triangle inequality, if Y is of magnitude in here, then there's no way that we could get this magnitude down to below delta over 3. So this implies that f of x equals 0. Because, so if f of x equals 0 on that one, again, this is not, the x minus y is not in V, so here we're going to get a 0, so the product is 0. And since it was for all y inside of V, since we get x minus y is not in V for all y outside of that ball, we end up with that this one is 0 when y is outside of the ball, and this one is 0 when y is inside the ball. So the integral is 0, so we get f of x equals 0. Then we say that the support of f is a subset of x such that p of x, k's distance is less than 2 delta over 3, because we showed that if p x k was greater than delta over 3, that the function must be 0. So we get that this is a subset of this set, and this one is obviously a subset of u by the definition of delta, since we chose delta to be the distance between k and the complement of uc. So from this, we get all three conditions. We have f of x equals 1 on k, and that the support of f of x is a subset of y. So this completes the proof and completes this presentation series on convolution. I will see you in functional analysis next semester.